Hello everyone, welcome back. So in this video we'll be talking about your averages or measures of central tendency. So in the previous video we had discussed about your frequency distribution and discrete and continuous series. So I hope you remember. So in the last video we had talked about this. So now let's move ahead. So basically we are studying descriptive statistics. Okay, so which is one part of your statistics, and then in the future videos we'll be studying your inferential statistics. So under descriptive statistics, what we do is we somehow try to describe the data, the kind of data that is available to us through certain numbers, certain averages. Okay, so instead of uh, talking about the entire data set, we try to find certain value that represent the entire population. Okay, that is what is basically called your averages or measures of central tendency. So values that are kind of representing the entire population. So instead of talking about the entire population, you can talk about those values, and those values will represent the population. So if I say that the average of 10 numbers is this, so it means that it's talking about, or it's giving an idea, that average value is giving an idea about the entire population of those 10 numbers. Okay, so they are also called measures of central tendency. The averages are also called measures of central tendency, because central, because this is where the values are moving towards in general. So a major part of the population, or the major values of the population, are confined or moving towards this central value. Okay, so there is a very high probability that the observations that I've taken will lie closer to a central value. Okay, so we'll talk about these things more deeply as we move ahead. So this is a general idea. So let's see what kind of averages are available to us that we'll be discussing here. So average of a statistical series is the value of the variable which is representative of the entire population. Okay, so जैसे we talked about the height of all the males in a city. Okay, so suppose we have the data for 100 people. Okay, now if I take the average of all the height, say it is equal to 165 centimeter. So on an in general I can say that this city, which has 100 males, has on an average a height of 165 centimeters. So overall, if I see, the general height in that city is equivalent to 165 centimeter. There might be some people who are above it, there are some people who are below it, but in general I can say that the average height of this city is 165 centimeters. So this is what average does, or this is how average helps us. It helps us in summarizing the entire data. Okay, मतलब हम लोग एक सिंगल टर्म से पूरी पॉपुलेशन को रिप्रेजेंट कर सकते हैं. दिस इज व्हाट दिस मीन्स. सो देर आर 5 measures of central tendency: arithmetic mean or simple mean. Okay, we have median, we have mode, we have geometric mean, and we have harmonic mean. So we'll discuss each of these one by one. Okay, so what is arithmetic mean? So this is the very basic thing. I think everybody knows this. It is basically the sum of observation divided by the number of observations. So you sum the observation, and suppose there are n terms, so you divide it by n. So that is your arithmetic mean, and this is how it is represented by x bar. So in case of frequency distribution, so if we have a frequency distribution, then what do? Say xi is the observation observation, and fi is the frequency. So you multiply the corresponding observation with the corresponding frequency, and you sum it for all the terms. So if suppose there are n terms, so you do that for all the n terms, and then you divide it by n by after summing it. So summation of xi multiplying both these terms into fi upon n, where n is equal to summation of fi, summation fi, because n here will be the sum of all the frequencies, because that is how or that many times is the observation being repeated. Okay, so you can go and check back in the previous video where we have discussed your frequency distribution. So this becomes the formula for your x bar if you have a frequency distribution given. 1 upon n summation of xi into fi. So you are basically summing this entire term. First you multiply these two terms and then you sum it for all the values. Now, in case of grouped or continuous frequency distribution, so if you have a distribution of this sort, how will you use the formula fi xi that we have just seen? So, in this case, you will take the midpoint of this class interval. So, since it's between 0 to 10, it means that the midpoint will be 5. So, these are the midpoints. Okay. Then you will multiply these two terms. Your f, which is the frequency, into x, that is the midpoint, and that is how you will solve it here for. Okay, I hope this is clear. And if x or f values are large, then you can use di. So if suppose the x values are very large, okay, and it is hard to do the calculation, then you can create a variable that is di, which is given by xi minus a, where a is a term from the list of xi itself. ओके जैसे यहाँ पे ये आपके एक्सरसाइज है सारे, तो यू कैन डू व्हाट, यू कैन सपोज अज्यूम दैट दिस इज योर ए, देन यू कैन create a di which is xi minus a. So for the first term here it will become 5 minus 35, similarly 15 minus 35, 25 minus 35, and this will go on, and then you will use this formula. So your x bar here will be x bar is equal to a plus 1 upon n, which is equal to summation fi into summation of fi into di. So यहाँ पे we are not doing fi into xi, we are doing fi into di. Okay, and this is how your formula will change. You will add a and then you will use this formula. So this is how you calculate your x bar here. So let's talk about the properties of arithmetic mean. So algebraic sum of the deviation of a set of values from the arithmetic mean is 0. So what this is saying that suppose x bar is your mean and xi are the values of which this is the mean. So deviation of these values from this mean and its sum is equal to 0. So whatever the sum of the deviation is of these values from the mean itself is equal to 0, because some values of xi will be less than your mean value and some values will be more than your mean value. So if you take the sum of deviation, so deviation is basically your gap. So let me take an example. So now suppose these are the xi's, okay, of which you have to calculate the mean. So suppose the mean of this number is 30. Okay, so you will, and you have to calculate the deviations. So deviations will be 5 minus 30, 15 minus 30, 25 minus 30, then 35 minus 30. So in here it will be minus 25, this will be plus 5. So this is what happens. So some deviations will be negative, some will be positive, and they will cancel out and the end result will be 0. So this is what this property means. So the sum of deviation of the values about the mean is equal to 0. मीन से जो दूरी है सारी टर्म्स की, अगर हम उनको ऐड करेंगे तो द एंड रिजल्ट विल बी 0, बिकॉज जो भी सब्ट्रैक्शन पे निकलेगा वो आपस में एक दूसरे को कैंसिल करके हमें नेट रिजल्ट 0 दे देगा. सो दिस इज एन इंपॉर्टेंट प्रॉपर्टी, जस्ट रिमेंबर दिस. algebraic sum of deviations of a set of values from their arithmetic mean is 0. Now the second property is the sum of squares of the deviation of a set of values is minimum taken about the mean. So if I take a number and subtract it from the values and take the square of it, okay, x, so this is, just look at this abhi. So I have taken a number a and I have subtracted it from the xi values and I have done the square of it, and if I multiply it with the frequency and add it for all the values of xi, then this sum this sum that I'm getting, which is represented by z, will be minimum if a is equal to x bar. That is your mean. So that is what this means. The sum of squares of the deviations of a set of values is minimum taken about the mean. So if this a is the mean of this series of this data, then this sum which is z will be minimum if it is taken around the mean. So this is what this means. So this property is basically used for dealing with variances when we talk about minimum variance and everything. So we'll see how this will be used. Okay, so now we have the third property, mean of composite series. So composite series is basically a mix of two or three or more series. Okay, so more than one series, if they are being mixed, okay, then it becomes a composite series. So if x bar I, where I is equal to 1 to k, are the mean of k component series ni, I equal to 1 to k respectively, then the mean x bar of the composite series obtained on combining the component series is given by. So if we have a composite series, if we have say series, some k series with xi bar as the mean, and if we create a composite series out of it, then the mean of the composite series is given by this formula. X bar, this is the mean of the composite series, is given by n1 into x1 bar. So basically n1 is the number of terms in the first series and x1 bar is the mean of the first series. Similarly, this is done for all the series. Say suppose there are k series. Okay, sorry. Say suppose there are k series. Okay, so you sum this for all the k series and you divide this entire thing by the number of terms of all the series combined. N1 is the number of term in the first series, N2 is the number of terms in the second series, and till the kth series. So this is how you calculate the mean of the composite series. So it can also be written in this form, summation I equal to 1 to k ni into xi upon summation I equal to 1 to k ni. So this is the proof of the series. So this is uh, x1 bar, which is given by 1 upon n1 into x11 plus x12. X11 means the first term of the first series. X12 means the second term of the first series. Similarly, this is the second series, the first term of the second series, the second term of the second series, and we do this for the k series. So this is how we calculate the mean of the first series, for the second series, for the kth series. And if I add these terms and divide by n1 plus n2, that is the number of terms in the entire composite series, then I get this. Okay, this is the proof of this, right? So I think this is all for this video. This was about arithmetic mean and its properties, right? So we'll discuss about the median in the next videos. So thank you for watching and have a nice day.